Hi students, this is Someshwara. Now we are discussing the JEE Main paper. It was conducted on 8th April afternoon session. Let's go to the paper discussion. Okay. First question is statement. The buffer solution is a mixture of salt and an acid or a base mixed in a particular quantity. Is a wrong statement because what is a buffer solution? A solution which resists a change in its pH even after adding a small amount of strong acid and strong base is called buffer solution. Buffer solution mainly classified into two categories. One is acidic buffer solution. Acidic buffer solution. It is a mixture of a weak acid and its salt with strong base. Example, CH3 COOH and CH3 COONA. At the same time, H2CO3 and NaHCO3 is a carbonic acid. Is present in our blood, is a naturally occurring buffer solution. Its pH value equal to around 7.4. At the same case, we are going to the basic buffer solution. Basic buffer solution. So it is a mixture of a weak base and it's a salt with strong acid. So a mixture of weak base and it's a salt with strong acid. Example, NH4OH plus NH4Cl. Okay, that is why here this is an acid or an base is wrong. Here is wrong. Compulsory it must be a weak acid or weak base. So this statement is incorrect. Then second one is blood is a naturally occurring buffer solution whose pH is maintained by H2CO3 and NaHCO3 concentration. This is a correct statement. That's why statement 1 is incorrect and statement 2 is correct. That is why statement option is this one. Clear? Buffer solution means a solution which resists its change in its pH even after adding of small acid or strong base. Okay, na? So buffer solutions a mixture of weak acid and salts with strong base. Otherwise, a mixture of weak acid and excess of strong base is given, then only act as buffer solution. Simply, in buffer solution, weak acid is excess reagent for acidic buffer solution. For basic buffer solution, weak base is a excess reagent. Okay. Next one. Identify the incorrect statement about the 15th group elements. What are the 15th group elements? Nitrogen, phosphorus, arsenic, antimony and bismuth. These are the 15th group elements. Next one. What is the first one? Dinitrogen is a diatomic gas which acts like an inert gas at room temperature. It's a correct statement because nitrogen N2, its bond order equal to 3, N triple bond N. Its bond dissociation energy is very high. Bond dissociation energy is around 945 kilojoule per mole. That's why this kind of energy is not available at room temperature. That's why it acts as a inert behavior. So this is a correct statement. Next one. The common oxidation states of these elements are -3, +3 and +5. This also correct. Reason is NS2, NP3. So its outermost electronic configuration is this is. That's why is able to accept 3 electrons and lose its 3 electrons or totally lost 5 electrons. -3, +3 and +5. Okay, no? Simply how many electrons are there? That is the plus or minus. Is a plus or minus. Next one is a total. Similarly, if you take NS2, NP4 is there. Now, what are the possibilities? 1, 2, 3, this one. Here -2, +2, +4 and +6. Okay, na? Then this is for 16th group elements. This is for 15th group elements. Okay. Now this also correct. Nitrogen has unique ability to form p-pi multiple bonds. This also correct. This also correct. Now nitrogen is able to form 5 oxides N2O, NO, N2O3, NO2 and N2O5. In our periodic table, an element which is able to show maximum number of oxide is nitrogen. These are 5. In these are neutral oxides. These are acidic oxide. Acidic. So finally 5 oxides are able. What is the reason? Is able to form p-pi bonds. Okay, is a correct statement. Now okay. Now then the stability of +5 oxidation state increases down is wrong. This is wrong because of inert pair effect. Inert pair effect. Then NS2, NP3. That is why generally from top to bottom oxidation state, the maximum showing of oxidation state, maximum oxidation state can be increased. But we go to the 15th group elements, not only 15th group, 13th group, 14th group and 15th group. Due to inert pair effect, what is the inert pair effect? Non-involvement of outermost NS2 electrons in bond formation. We are expecting +5, but due to inert pair effect, this is not participate. That's why it can show +3 oxidation state. So bismuth stable oxidation state is +3, not +5. Okay, that's why this is wrong. Nitrogen shows maximum covalency 6. This also wrong because maximum covalency of second period is 6. Sorry, maximum covalency of second period is 4. Second period is a 4 and third period is 6. Nitrogen maximum covalency equal to 4. That is 4 in ammonium ion. General covalency of nitrogen is 3. Then maximum covalency of nitrogen is 4 in ammonium ion. That's why nitrogen shows a maximum covalency 6 is wrong. Clear? Not only that, any second period element never show covalency 6. Okay, na? What is the answer for this one? We required incorrect statement. Incorrect statement is C, D and E. Option is this one. Is it clear? Due to high bond dissociation energy, this is inert behavior. Next, due to its electronic configuration -3, +3, +5 nitrogen able to show p-pi bonds. That's why nitrogen able to form maximum number of its oxides. Next one is its stable oxygen state is plus pi is wrong due to inert pair effect, and nitrogen can show maximum covalency is 6, that also wrong. Okay. Next one. When psi a and psi b are the wave functions of atomic orbitals, then sigma star is represented by, according to MOT, according to molecular orbital theory, then two atoms of atomic orbitals combine this is wave function of A, this is wave function of B, is a wave function of atom A, wave function of atom B. These are combined to form then. So, this is the energy level, is the wave function of atom A, this is atom B, okay. Then this is sigma, this is sigma star. Then is bonding molecular orbital, this is anti-bonding molecular orbital. So, bonding molecular orbital according to LCAO, linear combination of atomic orbitals, psi molecular orbital. Molecular orbitals formed due to combination of wave functions of atomic orbitals by addition and subtraction. So, this is psi A plus or minus psi B. Molecular orbitals formed by the addition and subtractions of wave functions of individual atomic orbitals. These are two. Plus means in phase overlapping or positive overlapping. That's why these are two types. Molecular orbitals two types. Bonding molecular orbital is equal to psi A plus psi B. Then this is represented by sigma. At the same time, anti-bonding molecular orbital equal to then negative overlapping, out of phase overlapping, then is B. This is also known as sigma star. That is why the when wave function psi A and psi B of atomic orbital sigma star is formed due to subtraction of wave functions of atomic orbitals. That's why this is a option. Clear? Addition of wave functions of two atomic orbital is the reason for formation of bonding molecular orbital, and subtraction of wave functions of two atomic orbitals are reason for formation of antibonding molecular orbital. So, okay, this is a LCO, linear combination of atomic orbitals. Okay. Next one. Identify the correct statements about the p block elements and their compounds. A. Non-metal have higher electronegativity than metals. Here, non-metals. Then generally they have electronegativity is high. Example, fluorine, oxygen, nitrogen. So, non-metal have high electronegativity than then is the correct statement. Okay, na? Next one. Non-metals have lower ionization enthalpy is wrong. So, for example, fluorine, you take his example is a fluorine, you take fluorine, chlorine, then oxygen. Okay, they have high ionization enthalpy. High ionization enthalpy. Okay, so this is a wrong statement. Next one. Compounds formed between highly active non-metals and highly active metals generally ionic. Yes, this is a correct. So, ionic bond means the electrostatic attraction forces between two oppositely charged ions is called ionic bond. Ionic bond generally formed between metals and non-metals. Okay, na? So, this is a correct statement. Next one. Non-metal oxides are generally basic is wrong. So, elements general, I don't go to the amphoteric, metals and non-metals. Metal oxides are generally oxide is a basic character, then alkaline character, then non-metal oxides are its oxides generally acidic character, acidic. Okay, then non-metal oxides are generally basic character is a wrong. Next one, metal oxides are generally acidic or neutral, this is a wrong. Okay, that is why what is the option? We want a correct options. What are the correct options? A and C. This is the option. Okay, na? Metals generally, metal oxides have basic character, non-metal oxides are acidic character. Metals have generally high electronegativity and high electron gain enthalpy and high ionization enthalpies than metals. Okay. Next one. Match the complexes versus their magnetic momentum. So, first one is Cr NH3 taken 6 plus 3. What is the chromium? Z equal to 24 and your oxidation number is, what is that, plus 3. Oxidation number is plus 3. Therefore, electronic configuration of Cr plus 3 is 4s. Here this is 4s1, 3d5. On this one 4s0, 3d3. Therefore, d orbital here 3 unpaired electrons are there. Therefore, is involved in D2 sp3 hybridization. Here hybridization is not our matter. We required magnetic momentum. What is the n value? N equal to 3. What is the formula for magnetic momentum? Mu equal to under root n into n plus 2 bm. What is the n value? N equal to number of unpaired electrons. Okay, na? That's why here what is the value of this one? Mu equal to under root 3 into 3 plus 2 equal to root 15. Root 15 equal to how much? 3.87. So, for this one option is 2 for this. Okay. Next one is second one. This is the A. we go to B, NiCl4 minus 2. What is the central atom? Central atom is nickel, Z equal to 28. Electronic configuration is outermost argon core 4s2 3d8. This is outermost electronic configuration. Nickel has 10 valency electrons. Okay. Now here what is the oxidation number? Oxidation number of nickel is plus 2. That's why electronic configuration of nickel plus 2 is 4s0 3d8. Clear? Now one, two, three, four. So this is 3D, this is 4s, this is 4p. Here how many electrons are there? Is a weak ligand. This is nickel is weak ligand. That's why 1, 2, 3, 4, 5, 6, 7, 8. So is involved in sp3 hybridization. So hybridization is not our matter. Okay. Now here how many unpaired electrons are there? Number of unpaired electrons are is equal to how much? Therefore magnetic momentum is mu equal to under root n into n plus 2 equal to 2 into 2 plus 2 then root 8. So 2.83 bm Bohr magneton. Now that's why second one. This is here 4. Next one. This is next one is COF6 is a weak ligand. Here minus 3. Cobalt Z equal to 27. Argon core 4s2 3d7. What is the electronic oxidation number? Oxidation number equal to plus 3. Therefore cobalt electronic configuration is 4s0 3d6 is a weak ligand. Weak ligand means obeys Hund's rule. Therefore here how many unpaired electrons are there in this one? 1, 2, 3, 4, 5, 6. So n equal to 4. It has, and then what is the hybridization of this one? Is involved in sp3 d2. That is the outer orbital complex, and n equal to 4. Mu equal to under root 4 into 4 plus 2 6. Here root 24. Here this is 4 point around 9 bm. Okay. This is C equal to 1. Next one is a strong ligand. Oppose the Hund's rule. Its magnetic momentum is 0. Then how to explain this one? Nickel Z equal to 28. 4s2 3d8 outermost electronic configuration argon core 4s2 3d8. What is the oxidation number is plus 2. Therefore electronic configuration of nickel 2 equal to electronic configuration of nickel plus 2 is 4s2 3d8. Then here cyanide ion is a strong ligand. Cyanide ion here Cn minus is a strong ligand. That's why opposes Hund's rule. Hund's rule. That means then 1, 2, 3, 4, 5, 6, 7, 8 then is involved in what type of hybridization? Is dsp2 hybridization. Then inner orbital complexes and dia, n equal to 0 diamagnetic. Okay. So okay na? That's why here what is the option for this one? Simple. This is a strong ligand or weak ligand is not a criteria. Anywhere then metal has d electrons, there is no criteria for weak ligand and strong ligand. Okay. That's why this is chromium all coordination number 6 complex compound, then coordination number of 6 and chromium oxygen state equal to +3 is always involved in D2 sp3 hybridization, inner orbital complexes and 3 unpaired electrons, magnetic momentum is 3.87. So chromium complexes never checked. This is a direct we go to answered. Okay. So what is the option for this one? 2, 2, 4, 1, 3. Option is 3. Okay na? Okay. Now next one, the equilibrium of dichromate ion and chromate ion. So we know that Cr2O7, this is dichromate, then exist in equilibrium with CrO4 minus 2. This is chromate. Chromate. Then what is the color? Color is, this is orange yellow. Orange yellow color or orange red. This is orange red. And one more important point is, we know that acidified potassium dichromate act as oxidizing agent. So is exist in acidic medium, is exist in basic medium. Therefore in the basic medium, then chromate ion is exist. At the same time acidic medium dichromate can exist. That's why here we want equilibrium shift towards, in which direction? Towards chromate ion. Is a chromate ion, that is in basic medium this equilibrium is favored to forward reaction. That's why here what is the required? This is a chromate, that is a basic medium. Option is this one. Okay. Next one of the important bits, EMF of the cell thallium and its thallium ion, its concentration is 0.001 molar, Cu plus 2 concentration is 0.01 and Cu. Then their EMF value is given 0.83 volt. Then what could be the increased by? Then listen, according to Nernst equation, Nernst equation, E cell equal to E0 cell minus 0.059 by n log quotient. According to this one, what is the cell reaction? Is the notation is given. What is the cell notation? Cell representation or notation. This is a thallium plus ion aqueous solution. Its concentration is 10 power minus 3 molar double bar, that means salt bridge. Then Cu plus, what is the concentration? 10 power minus 2, then bar Cu. What is the cell reaction? Cell reaction is at anode, that means at LHS, at anode, this side, thallium gives rise to thallium plus electron. This is oxidation. At the same time, at cathode, Cu plus is already solid, is aqueous. This is plus electron gives rise to Cu, is a solid, is aqueous. Then what is the total reaction? Thallium solid plus Cu plus, this is aqueous, gives rise to thallium plus aqueous, Cu plus 2 solid. This is a net equation. Okay na? Simple trick. Don't write this kind of equation in examination hall. Time taken process. Simple method is, these two are reactants, these two are products. What are those? Here, these two are reactants, these two are products. This one, these are clear. Now, what is the quotient value? Quotient equal to product concentration by reactant concentrations. What are the products? These are already solid. Active mass equal to 1. That is why thallium plus concentration by, what is that? Cu plus concentration. Okay na? This is a net. Okay. Now, you are going to that. Here, Nernst equation. E cell equal to E0 cell minus 0.059 by n log, what is the quotient? Quotient is thallium plus concentration, by Cu plus concentration. Okay na? You observed here, according to this one, quotient increases, log Q value increases, this part increases, that's why E cell value decreases. Okay. Quotient increases, log Q value increases, net E cell value decreases. Now, I am taking is a reverse way. I am taking this one. What is that? E cell equal to E0 cell plus 0.059 by n. What is the nth factor equal to here? 1. Nth factor equal to 1. Then next one, log, it's you take a reverse. What is that? Cu plus concentration by thallium ion concentration. And then what you observe here, copper concentration increases, then quotient value increases, E cell value increases. That is why simple one, cathode compartment concentration increases. Simple logic. In the electrochemical cell, the concentration of cathode compartment increases, E cell value increases. Simple logic. That is why here what is the cathode compartment? This is a cathode compartment. So copper ion concentration increases, then E cell value increases. So increase the concentration of then. So here I think this is a 2. This is a 2. Now here we go to this one. At that time equation some kind of error is there. Okay, anywhere here consider then cathode compartment concentration increases. What happened? E cell value increases. Okay, answer is this one. If you take here thallium plus double bar Cu plus 2, here Cu plus is there, that's why based on that one I have written. Now Cu and then this is a 10 power minus 3, this is 10 power minus 2. What is the cell reaction? You take this one, LHS. Thallium gives rise to thallium plus electron RHS, that means at cathode, Cu plus 2 plus 2 electrons gives rise to Cu. That's why is multiplied by 2. So what is the net equation? Net equation is 2 thallium solid plus Cu plus 2 aqueous gives rise to thallium 2 thallium plus Cu. In this way nth factor equal to 2. Therefore, according to this equation, what is the quotient value? Quotient equal to product concentration by reactant concentration equal to thallium plus concentration whole square by Cu plus 2 ion concentration. Okay, na? So either you take this one and that one, anywhere the cathode compartment concentration increases, then only E cell value. Okay, na? Option is this one. Okay, na? Finally, we want to increase the EMF of the one electrochemical cell. Two cases. One is concentration of cathode compartment increases or concentration of anode compartment decreases. Then only quotient value decreases. Then E cell value increases. Okay. Now, here, what is the A? Aniline, then subjected to diazotization. Diazotization. NaNO2 plus HCl at 0 to 5 degree Celsius, we get benzene diazonium chloride. Then is treated with then H2O, H2O, warmed condition, then this is only at 0 to 5 degrees Celsius is stable. Just this temperature rises from 0 degrees Celsius to or 5 degrees Celsius to 10 degrees Celsius. Immediately this reacts with water to form is a phenol. Phenol plus N2 plus N2 plus HCl. This is a phenol. Okay, so this option is 1, this is a 3. Okay, next one is, second one is here phenol is stored in long period with in the presence of sunlight, is easily oxidized with atmospheric air, easily converted into what is that? This is conjugated diketone, that is a benzoquinone, is a orange dark red color solution. Generally phenol is a colorless, but is exposed with the sunlight and atmospheric air, slowly it changes color from colorless to then dark red color. This is a general, but that is a slow process. We are using chromyl chloride or chromic acid, immediately is converted into this one. So is a phenol phenol 1 is treated with chromic acid oxidation. What is that? This is Na2Cr2O7 and H2SO4. Then or chromyl chloride CrO2Cl2 or stored in long time, long period in air, atmospheric air in the presence of sunlight, it changes to oxidizes to is a benzoquinone, that is conjugated diketone, is a family is conjugate diketone, that is benzoquinone. Quinone is a red, dark red color. Okay, na? Now, so this is a 4. Next one is a Reamer-Tiemann reaction. Is a Reamer-Tiemann reaction. So phenol changes to then salcylaldehyde is a major product, that is 1. This is coal base reaction. Coal base. This is a Reamer-Tiemann reaction is a coal base reaction, that is salicylic acid is a 3. Okay, so option is 3, 4, 3. First one is this is phenol is a 2, no? This is a 2. 2. So 2, 4, 1, 3. Option is 1. Is 1. Okay, na? Clear? Now, a reaction A gives rise to B K1, B gives rise to C K2. The rate of formation of B is set to be 0, then the concentration of B is given by, then A gives rise to is a B is a K1. This is here C, this is a K2. Now this to this one is what is that? Formation of B. Formation of B. Formation of B. This to this one what is that? Decomposition of then decomposition or decay of is a B. Therefore, according to rate law is equal to what is that? Rate of formation. Rate of formation of B, rate of formation of B is equal to what is the value? Plus dB by dt is equal to what is that? K1 into concentration of A reverse. Then K2 into concentration of B. This value is given is equal to 0. Is given. Therefore, here K1 into concentration of A minus K2 into concentration of B equal to 0. Therefore, K1A is equal to K2 into concentration of B. Clear? Therefore, what is required? Then concentration of B equal to K1 by K2 into concentration of A. Okay, na? Now, what is the option? This one. Option is this one. Okay. Next one. Which of the following compounds will readily react with diluted NaOH? Is a regularly confusing question for the student. Very simple. Alcohols are feeble acids. That's why never reacts with diluted bases or what is that? Bases. These are the bases. But these are soluble in strong bases like alkali metals, sodamide, Grignard reagent. But is not soluble in regular alkali metal hydroxides. That is why here is a alcohol, is a phenol, is a alcohol. This is nothing but this is CH3, CH3 and this is OH, is also alcohol. Then this is a benzyl alcohol. So option is this one. So I give the simple hint. Then you go to alcohols, then phenol, then carboxylic acids. Carboxylic acids. Carboxylic acids. Okay. Then here then NaOH or KOH. Next one is Na NH2, then RMGX, Grignard reagents. Next one is sodium bicarbonate or alkali metals. One more is then alkali metals. Then here this is okay, is a participated. No. Here is no. Phenols is a react with this one here and this one is no. Carboxylic acids, yes, that is clear. NaOH or KOH. Okay, important table. Okay. Next Kjeldahl method is applicable for estimation of nitrogen in pyridine. Is wrong. Wrong. So, Kjeldahl method is not applicable for Kjeldahl method is not applicable for 1. Nitro compounds like nitrobenzene or nitroalkenes. Next one is azo compounds. Then N double bond N, that is azobenzene. Next one diazo compounds. Like benzene diazonium chloride. Next one is nitrogen in ring compounds. Ring compounds like these are okay na? So wrong. What is the reason? These compounds do not converted into ammonium sulfate under given conditions. What is the reason? These compounds do not convert into ammonium sulfate at that condition. Under this condition. At what condition you are doing the Kjeldahl method? At that condition is not suitable for conversion of these compound to ammonium sulfate. Okay na? So, what is the second statement? The nitrogen present in pyridine can easily converted into. This is a wrong. Okay? These are the limitations. So, what is our answer? Both are wrong statements. Both statements are false. Is it clear? Next one. So, here Bayer test, then A. Bayer test is nothing but cold dilute alkaline KMnO4. Is a pink color is there? Pink. Okay. Is useful for the identification of unsaturated compounds. Unsaturated. So, what is that? This is unsaturated is a 4. Next one is B. Ceric ammonium nitrate is useful for the testing of alcohols. B. CAN. Then NH4 taken twice, Ca, NO3 taken 6 is alcohol. Then we get Ca, NO3 taken 4, CH3, OH taken twice is a red color complex. Red color plus 2 NH4 NO3. This is alcohols. So, this is for alcohols. This is 3. Okay. Next, what is the phthalate dye test? What is the phthalate dye test? Preparation of phenolphthalein indicator. That means here C phthalic anhydride reacts with phenol 2 moles. Then in the presence of H2SO4, in the presence of acidic medium, this is O, this is a double bond. In this one, OH, this is OH plus here plus H2O. This is a phenol. This is indicator. Acid base indicator is there na? That is phenolphthalein indicator. So this is used for C. C4 is phenolphthalein. Next one is Schiff's base, is useful for the a pararosanilin hydrochloride, is a pink color, is that pink color is decolorized by SO2 gas. Then this colorless reagent is added to aldehydes, is restored its pink color. So this is for 2. What is the option? 4, 3. Only one is there. 4. Okay, 4, 3, 1, 2. Option is this one. Okay. In this case here, what is going on? This is removed as a water. This is the structure of the phenolphthalein indicator. This is acid base indicator. This test is called phthalate test. Okay, clear? Finally, Bayer's reagent for identification of alkenes and alkynes is a pink color. Is when is adding decolorized. Steric ammonium nitrate is used for identification of alcohol in laboratory. Then phthalate test is used for identification of phenol in the laboratory. Schiff's base is Schiff's reagent is used for identification of aldehydes. Clear? Then next one, the shape of the carbocation. So what is the carbocation? This is nothing but is a simple carbocation. Carbocation means what is the positive means vacant orbital. This is nice. Involved in sp2 hybridization, then trigonal planar. Okay na? There is a trigonal planar. Okay. Next one. In quantitative test for identification of presence of phosphorus, the compound is heated and oxidizing agent, which is further treated with nitric acid and ammonium molybdate. So you get a canary yellow precipitate, that is for the compound is, this is the answer. Here what is going on? First of all, given sample is an unknown organic compound is given, that is heated with oxidizing agents like sodium peroxide or nitric acid. Phosphorus present in organic compound is oxidized to phosphate. that phosphate is treated with diluted acid to form a phosphoric acid. This phosphoric acid is treated with ammonium molybdate. You get a canary yellow colored ammonium phosphomolybdate. What is the name of this one? Ammonium phosphomolybdate. Okay, its molecular mass is 1877. Okay, now what is the process of this one? Phosphorus present in unknown organic compound is heated with oxidizing agents like sodium peroxide. Phosphorus present in organic compound, oxidized to phosphate, that is Na3PO4 plus Na2O. So its nth factor equal to is a 5, is it 2. Okay, that is why this is a 2, this is a 2. Okay, this is a phosphate. Okay, na? Phosphorus present in the unknown organic compound treated with oxidizing agent. Phosphorus present in compound oxidized to phosphate is the first step. Now this is what he said, that is treated with the acid. Na3PO4 is treated with nitric acid, acidification. Then it changes to phosphoric acid. H3PO4 plus, and then next one is 3NaNO3 is a phosphoric acid. Okay, now this is treated with H3PO4 plus ammonium molybdate, NH4 twice MoO4, then again nitric acid gives rise to ammonium phospho 12 MoO3, then plus ammonium nitrate plus H2O. Then this is a 12, this is a 21, because here 12 is there. This is a 21, this is a 12. This is a 12. This is yellow color. Yellow. Clear? Basis. Okay. This is a process. Get a clarity? Then next one. Given two statements, all of the compounds reacts with para-toluene sulfonyl chloride, that is nowadays is used as a Hinsberg reagent. What is the Hinsberg reagent? Benzene sulfonyl chloride, this is then Hinsberg reagent. Nowadays in that place we are using then SO2Cl, this is para-toluene sulfonyl chloride, this is okay na. Now here what are the compound? Is a primary amine, secondary amine, tertiary amine, is a wrong. This is wrong, because primary amines are NH2 treated with SO2Cl, then CH3 gives rise to RNH. Here this one and this Cl is removed. Then NH, RNH, SO2, here CH3 is a white precipitate, and here acidic hydrogen is there. Here acidic hydrogen, that's why is a soluble in NaOH. That is. Next one is now second one, secondary amines. Secondary amines are NH, this is R, SO2Cl and CH3 here. There is no active hydrogen, that's why is also white precipitate, but insoluble in white PPT, insoluble in NaOH because there is no acidic hydrogen. Tertiary amines are here. There is no active hydrogen, then CH3, there is no reaction. Okay. So what is the first statement? All compounds is wrong. Their compounds in the reaction are soluble. So this also wrong. Both are wrong. Both statements are wrong is option. Clear? Directly Hinsberg reagent is useful for the identification of primary, secondary, tertiary amines. Okay. Next one. The correct sequel of acidic order of following aliphatic acids. We know that acidic order is directly proportional to electron withdrawing group. Okay, now at the same time is inversely proportional to electron releasing groups. So here this group is there. Alkyl groups are electron releasing groups. That's why alkyl groups increases, then acidic character decreases. That is why here there is no alkyl group, one alkyl group, two alkyl group, three. That's why this is order. Okay. Next one. SN2 reaction are stereospecific, indicated that they result in the formation of only one stereoisomer in the product is a correct statement, because in SN2 reaction nucleophile attack from the back side of the leaving group, that means exactly 180 degrees from the leaving group. That is why Walden inversion takes place, we get the inversion product. Next one, SN1 reaction generally formation of product is the racemic mixture, because is also correct statement. In this one, in SN1 reaction, carbocation will be formed. Previously discussed, carbocation is sp2 hybridization is a planar structure. That's why nucleophile attack from the direct and exactly backside. You get the 50% approximately, not exactly 50-50. Okay, na? Is able to form racemic mixture. Okay, na? This is able to form leaving group is from this side and to form a carbocation, and then nucleophile attack from the both sides to form racemic mixture. Okay, na? Is a two steps process, is a single step process. So both statements are correct. This is answer. Next one. Fusion of MnO2 with KOH on oxidizing agent gives dark Mn K2MnO4 is a correct. Next one is the manganate ion on electrolytic oxidation in alkaline medium gives permanganate ion. This also correct. So this is a process of preparation of KMnO4. KMnO4 prepared in two stages. What is the stage 1? 1. Two steps are there. Stage 1, conversion of MnO2 to K2 is a black color, then K2MnO4. This is a dark green color. Is a dark green color. Next, step 2, conversion of K2MnO4 to KMnO4. These are the two steps. In first step, here MnO2 is heated with an alkali metal oxide or hydroxide, that means KOH or NaOH, in the presence of oxidizing agent like oxygen or potassium nitrate, then is strongly heated to form K2MnO4 plus H2O, then H2O. This is oxidizing agent. This is 4, here 2, here 2. Hydrogens how many? This is 2. Is a green color, dark green color. This is a dark green color. This is a statement. Second one is this to this one, second stage. Then potassium manganate is subjected to electrolytic oxidation to form manganate ion, permanganate ion. What is the first step? Second one is MnO4 minus 2 subjected to electrolytic oxidation in the presence of alkaline medium, and then you get MnO4 minus plus electron. This is at anode reaction. Okay, this also correct statement. Both statements are correct. Both statements. That. Statement 1 is fusion of MnO2 with KOH and oxidizing agent gives dark green color. This is correct. Next one, manganate ion. This is a manganate ion on electrolytic oxidation in alkaline medium gives manganate ion. Is correct. Okay. Next one, IUPAC nomenclature. You are giving the numbering from 1, 2, 3, 4, 5, 6, 7 and 8. So, what is the name of this one? 2, 5, 6 trimethyl octane. This is a compound. Okay. Next one. According to this, what is the given reaction? Half H2 plus AgCl solid gives rise to H plus aqueous, then Cl minus aqueous plus Ag solid. Here, what is the oxidation state of this one? 0. Here plus 1. This is minus 1. This is 0. So, what is the oxidation process? Oxidation is nothing but this is the oxidation. This is oxidation. That is electrochemical cell left side. At the same time, this to this one. This is reduction. Therefore, LHS, that means at anode, half H2 gives rise to H plus electron. This is oxidation. This is a gas. This is aqueous. RHS at cathode, then AgCl plus electron gives rise to Ag plus Cl minus is a solid. This is aqueous. Okay, na? Net reaction is this one. Net. So, what is the cell representation? Oxidation half part placed at the left side. Reduction part is placed at the right side. So, what is the net reaction? This is half H2 plus then AgCl gives rise to H plus Ag plus Cl minus. This is what the cell notation representation? PT H2 gas, then bar, what is that? Cl, KAgCl, na? What is that? Is a HCl solution. HCl double bar is a double bar. Okay. Next one is AgCl solid Ag. Then, okay. What is the answer for this one? This is okay, na? The molarity of an aqueous solution of urea is 4.44 molal. What is the mole fraction of urea? Now, mole fraction of solute by mole fraction of solvent equal to MB by 1000. Here M equal to molality, B equal to molecular mass of solvent. Then we want mole fraction of the solute. Here X by 1 minus X equal to, what is the molality? Is the 4.44 into molecular mass, aqueous solution, that's why this is 18 by 1000. That means 4.44 by 55.55 is equal to 0.44 by is 5.55 is around 0.08. Therefore, here what is the X value? X equal to, here X equal to 1 minus X into 0.08. X 0.08 Therefore, 1.00 X equal to 0.08. Therefore, mole fraction of then solute urea X equal to how much? 0.08 by 1.08, around 0.074 equal to 74 into 10 power minus 3. Then, okay, na? Answer is 74. Okay. Now, how to get this one? You get a doubt. How to get this one? I give the clarity. Then, mole fraction of solute by mole fraction of solvent equal to N1 by N1 plus N2 by N2 by N1 plus N2. Here N1 equal to moles of solute, N2 equal to moles of solvent. Okay, na? Now here this one cancel, remaining is equal to N1 by N2. So mole fraction of solute by mole fraction of solvent equal to small w by A by capital W by B. Small w equal to weight of solute, molecular mass of solute, weight of solvent, molecular mass of solvent is equal to W by A into B by capital W is equal to W by A into 1000 by W into B by 1000. This is, I use the 1000 by 1000, again 1. So this is molality is a B 1000. So mole fraction of solute by mole fraction of solvent. Then mole fraction of solute plus solvent equal to 1. Therefore, mole fraction of solvent equal to 1 minus mole fraction of solute. Clear? Then, okay. Next one. Total number of carbon atoms present in the tyrosine. So, this kind of questions is only by hearting. Therefore, simple way, glycine is there. NH2COOH NH2 is a glycine. Next version is the year. Then this is remote. In that place we are using CH3, that is the alanine. What is the next one? From this one, this is remote. You are using benzene ring. This is phenylalanine. This is phenylalanine. From this one, here OH is there. That is, this is tyrosine. Glycine, alanine, phenylalanine. This is hydroxyphenylalanine, para hydroxyphenylalanine. So how many carbons are there? 1, 2, 3, and this is 6. 6 plus 3, 9. Answer is 9. Okay, na? Next one. Enthalpy of vaporization of water is plus 40.79 kilojoule per mole at 1 bar and 100 degree Celsius. The change in internal energy for this vaporization under the same condition. Okay. Therefore, first one is H2O liquid, then H2O vapor. Okay, na? What is the delta N value? Delta N equal to 1. 1 minus 0, 1. Okay, na? What is the relation between them? Delta H equal to delta U plus delta N into RT. We want to find out what is that delta H. This is required. Then what is the RT value? Delta U is already, delta H already is given. What is the value? 40.79 kilojoule per mole. kilojoule per mole. Next one is next. What is the R value? 8.314 joule. Next T value equal to how much? 100. 100 plus 273 equal to 373. We want RT value. Then this is in joule, in kilojoule. 8.3 into 10 power minus 3 into 373 is equal to 8.3 into 0.373 is equal to 373, 83 is a 9, is a 21, is a 9, 11, next 24, 56, then 24, 29, and then 9, 5, 9, then what is the value? 0, and then this is okay, is what is the value? 3.09 approximately. This is okay na. Now so what is the value of this one? Delta H equal to what is the value? Delta H 40.79, then delta U plus 1 into this in kilojoule, that also in kilojoule, into 3.09. Therefore, delta U equal to 40.79 minus 3.09. Then this is a 37.7 is around in complete number equal to what is that? 38 kilojoule per mole. Okay na? Okay. Next one. 2 moles of benzaldehyde and 1 mole of acetone under alkaline condition and heating, that is called Aldol condensation. Aldol condensation. Therefore, here what is that? Benzaldehyde 2 moles 1 mole of acetone CH3 acetone, then benzaldehyde, then CH is a double bond O, then one more is H. That is why due to heating then base and heated, then we get product is then CH double bond, then here CH double bond, here C is a double bond, and then indirectly this one. How many pi bonds are there? Number of pi bonds equal to here in the 3, here 1, here 1, here 1, here 3, and totally 9. Clear? Next one. Number of molecules having bond order 2 from the following molecules. Okay. Then total electrons in chemical species and its bond order. Bond order. Then here 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. These are the total electrons, either molecule or ion. Its bond order is here. Then 14 electrons, value equal to 3. 1 electron increase or 1 electron decreases than 14, its bond order decreased by 0.5 unit. So this is 2.5 is 2, 1.5, this is 1.0, 0.5, 0. Similarly, this is a 2.5, this is a 2, this is 1.5, this is 1. Now C2 you take, C2. How many electrons are there in C2? 6 plus 6 equal to 12. 12 bond order equal to 2. Next O2, 8 plus 8 equal to 16. 16 bond order equal to 2. Next one. Here Be2. Then how many are there? Then if you want below that, and then one more. Here electrons are 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 electrons. Then its bond order is Then 4 electrons bond order 0, 8 electrons bond order 0, even number is 1, odd number is 0.5. Then we get a clarity. Now here Be2, how many electrons are there? Be2, hydrogen, lithium, beryllium. Then what is the atomic number? 4. 4 plus then atomic number hydrogen, helium, lithium, beryllium. 4 plus 4 equal to 8. Its bond order equal to 0. Next one, lithium 2. Atomic number hydrogen, helium, lithium. 3 plus 3 equal to 6. Bond order 1. Helium 2. 2 plus 2 equal to 4 equal to 0. Okay na? So how many are there? This is option is 2. You can practice this one, easy method. Okay. Next one. Total number of optically active compounds in this one. Here this is a plane of symmetry is there. here plane of symmetry. So this is not a optically active. In this one, 3 chiral centers are there. This is a pseudo chiral carbon. Pseudo chiral carbon means then a chiral carbon, a carbon has 2 identical chiral carbons and 2 different atoms are there that act as a pseudo chiral. So this is a pseudo chiral, is optically active. So here this is no optically active, there is no chiral carbon. Here chiral center is there. Here there is no chiral center, this also there is no chiral center. Option is this one and this one, option 2. Okay, na? Next one. A solution is prepared by adding 1 mole of ethyl alcohol and 9 moles of water. The mass percentage of solute. What is the mass percentage? Mass percentage equal to percentage of mass equal to small w by small w plus capital W into 100. What is the small w? Weight of solute. Capital W, weight of solvent. Okay, na? Now we go to here. What is the solute? N equal to weight by molecular mass. Therefore, weight or mass equal to mole into molecular mass. Okay, na? Mole equal to weight by molecular mass. Then weight equal to mole into molecular mass. Therefore, we go to the 1 mole of ethyl alcohol. C2H5OH. Its molecular mass is 46. How many moles are there? Weight equal to 1 into 46 equal to 46 is a small w. Next, what is that? Water. Then its molecular mass equal to 18. How many moles are there? Then 9 into 18. That is a 162. Capital W. Now small w plus capital W equal to how much? Small w plus capital W equal to 208, na? 208. 8, 10, okay. Now you substitute there. Small w, how much? 46 by 208 into 100. 46 by 2.08. Okay, na? This equal to 23 by 1.04 is equal to 22.11. So answer is 22. Clear? Next one. Next, here the total number of unpaired electrons in the compound. Here, unpaired electrons. We go to first complex is CONH3 taken 6 plus 3 plus 3. Here this is a strong ligand. Cobalt Z equal to central atom is cobalt. Its Z value equal to how much? 27. What is the electronic configuration? Electronic configuration is argon core 4s2 3d7. What is the oxidation number? Oxidation number equal to plus 3. Therefore, cobalt plus 3. Electronic configuration is 4s 0 3d6 na? Now is a strong ligand. Electronic configuration of cobalt plus 3 in complex. Then this is a strong ligand. is T2G and EG. This is 3D, 4S, 4P. Here 1, 2, 3, 4, 5 and 6. So this is involved in what is the hybridization of this one? Is the ligand. Then each ligand provide 2 electrons. Then NH3 this is D2sp3. Here how many unpaired electrons are there? 0. So in this one number of unpaired electrons equal to 0 for this compound, this complex compound. One more is there. There is a weak ligand. We go to NiCl4. So this is central atom is nickel. Z equal to 28. Electronic configuration is argon core 4s2 3d8. Oxidation number is +2. Nickel +2. Electronic configuration is 4s0 3d8 is a weak ligand. Therefore, (3D) 4s 4p. Then here 1, 2, 3, 4, 5, 6, 7, 8. 8. So is involved in 1, 2, 3, 4 is a sp3 hybridization. It has number of unpaired electrons equal to number of unpaired electrons equal to 2. Therefore, total equal 0 plus 2 equal to 2. Okay. This is okay now. Next one. The total number of aromatic compounds among the following compounds. What is the aromatic rule? Haeckel rule is Haeckel's rule. Cyclic, planar, conjugate, compound contain 4n plus 2 pi electrons. 4n plus 2 pi electrons cloud can show aromaticity. This is okay now. Here there is no conjugation. A conjugation is there. There is no here double bond, single bond, double bond. Here there is no aromaticity. Here there is no aromaticity. Here is how many 4 electrons. This is non-aromatic. This also non-aromatic. Then this is anti-aromatic. We are expecting this is anti-aromatic, but is non-aromatic. This is non-aromatic. This is anti-aromatic because it has a tub shape. Planarity is missing. Then now this is aromatic. This is non-aromatic. Option only one. Option is this is only aromatic. Okay, no? Now the wave number of a radiation having 5800 angstrom unit wavelength is x into 10 centimeter inverse. What is the value of x? nu bar equal to 1 by lambda is equal to, we required, what is the required? This is, we required nu bar equal to 1 by lambda. Our required is nothing but wavelength equal to 1 by nu bar. This equal to 1 by 5800 into 10 power minus 8 centimeters. 1 angstrom unit equal to 10 power minus 8 centimeters or 10 power minus 10 meters. We required that one. This is 1 by what is that, 5.8 into 10 power minus 8 is equal to 1 by 5.8 into, this is a 10 power is a 5 is equal to 10 into 10.4 by this is, okay na, is nothing but this is 0.1724 into 10 cube into 10. Okay, this value equal to 1724 into 10, that is a centimeter inverse. Sorry, then the wave number of wavelength, then nu bar equal to 1 by lambda. So lambda equal to this one is equal to 5.8 into 10 cube into 10 power minus 8. Now this is 5.8 into 10 power minus 5, that is in centimeters. Okay na, this is okay, option is 1724. Okay, thank you.
എൻട്രൻസ് സംബന്ധമായ വാർത്തകളും അപ്ഡേഷനുകളും ഏറ്റവും വേഗം ആധികാരികമായി അറിയാൻ ബ്രില്യൻറ്റ് സ്റ്റഡി സെന്റർ പാല യൂട്യൂബ് ചാനൽ സബ്സ്ക്രൈബ് ചെയ്യുക, ബെൽ ഐക്കൺ അമർത്തുക. ഈ വീഡിയോ മറ്റ് സുഹൃത്തുക്കളിലേക്കും ഷെയർ ചെയ്ത് നൽകുക.